Next in line, we have our third presenter, Naveed Tavakol from Biomedical Engineering, will present Astronaut on a Chip, bioengineered human tissue for studying cosmic radiation. Thank you.
Over 100 million miles, 9 months. That's how long it takes an astronaut to go from Earth to Mars. And on this journey, astronauts are exposed to a number of different stressors that impact their human health. A lot of these stressors, we don't really know what they'll do. What we do know is that the effect of cosmic radiation damage on these human tissues is going to be large. We know radiation itself can impact human health. We know that in cancer therapy, it's an effective measure to treat tumors. But we also understand that in nuclear disasters, radiation can cause the incremental increase in cancers over time. And this is not seen until years later. And so in my thesis work, what I'm hoping to do and what I've done is really focus on bioengineering tools to study human health in a dish and to model some of the effects of different organs in human cells. And so using these platforms, we can better understand how astronauts might be exposed to radiation over long duration flights. And so all we need to do this is a sample of blood, astronaut blood. We can then derive stem cells from this blood sample, make any cell type in the body, from bone cells to heart cells to blood cells, and then combine these cells with other microenvironmental factors to make a model, a millimeter-sized model of each organ. And these organs can then function into different capabilities that can mimic what the organ actually is seeing in the body. And so what we hope to do in this work, and what we've done, is really focus on engineering these models and then combining them together in a platform to look at how each organ can talk to each other. So like the body sends signals between one organ and another in situations of stress, we're able to mimic some of these functions in a dish. And once we mimic these functions, we can see in injury, one organ will send signals to the bone marrow, the site of blood and immune production, and recruit cells to this injured site. And so we use these platforms, and what I've done in my thesis work is use this platform to expose it to low levels of radiation, the types of radiation exposures you'll see in space, and then study the effects of these tissues over the long duration of multiple weeks. And what we found in this work is that the tissues exposed to these low levels of radiation have increased cardiovascular disease, increased inflammation, and also indications of potential cancer progression, which will mimic some of what astronauts might see in space. And so hopefully I'll be able to use these platforms in the future to enable the new development of radioprotective drugs that can prevent astronauts in these long duration missions and use this for translational impact. Thank you.